In this video we are going to talk about vectors, and more specifically we're going to actually talk about position vectors. So let's start by drawing ourselves a vector. We're going to start from the origin and we're going to go to point A, and we have the vector OA. And we can find the position of vector OA by counting over the number of x positions that we move and up the number of y positions we move. We can see that we move in a positive 3 and a positive 5. So positive 3 spaces on our x, positive 5 spaces on our y. Now let's draw a second vector. This is going to be vector AB. So vector AB, it moves across on our x-axis, but it does not move up or down on our y-axis. So that's just going to have a measurement or a placement of 7, 0. Now we're going to put in a third vector here. This is going to be vector OA. Hold on, not OA. This is going to be OB. We're going to from the origin to B, and we're going to try and find out how far have we moved from 0 to B. So we're going to look at how we can find that by simply finding the resultant vector. This is called the resultant vector, a vector OB. So the resultant vector OB is going to be the sum of OA and OA and AB. So we're just adding up our distances between the two. So we can find that just by putting our positions in there. We've got 3, 5, and 7, 0, and we add those together, we get 10, 5. And if we count over, we move 10 spaces in our x and 5 spaces in our y, and we can see that from the origin to B, to position B, so OB, we have indeed moved 10 spaces in the x and 5 spaces in the y. So it's just a simple matter of adding those two vectors together. Let's look at another example. So we've got, again, vector OA. This one's positioned a little bit differently, but if we count over where we're at, we can see that this is at position 4, 8. So we've moved 4 positions in the x direction, the positive x direction, 8 spaces in the positive y direction. And here's a second vector. It's going to be OB. And OB, if we count over and up, again, these are all positive vectors. So if we count over, we see that we've moved 6 in the x and 3 in the y. Now we want to know what position vector AB is, our resultant vector AB. Now, if you notice the difference between this second example and the first example is the first example we have OA and AB, we call it heel to toe. So the bottom of the arrow of AB meets the top of the arrow of OA. So they're kind of following a path. In the second example, they both come from the origin. So in order to find our resultant vector of AB, we have to have that same pathway. We have to have our original two vectors heel to toe. So what we can do is we can reverse the direction of one of them. We're going to just reverse A or OA, and we're going to find it to be vector AO. So now our starting point is going to be at A going towards O. Now what's the relationship between these? Well, AO is going to be the same thing as the negative direction of OA. Exact same spacing. The only difference is we're going in a different direction. So if we take that same idea, that negative, it's just going in the negative direction, we can apply that to the spacing. So negative 1 of 4, 8 is going to give us negative 4, negative 8 spaces for our positioning. So when we try and find the vector AB, we are now adding together AO plus OB, right? So AO plus OB. So when we add those together, we have negative 4, 8 for our AO and 6, 3 for our OB. We do our simple mathematics and we get the position of 2, negative 5. And if we count over and down, we can see that we did indeed move 2 spaces in the positive for our x and negative 5 spaces down for our y. So the resultant vector AB has the position of 2, -5. Now there is another way we could do this. So let's get rid of this. And our other way is just through subtraction. So we could do OB minus OA. So all we're doing is taking our OA and we're subtracting it. It's the same thing as above. Instead of using addition, we're now just going to be using subtraction. So we plug in our two values, 6, 3, and OA, if we look at the blue, it's 4, 8. So all we're going to do is subtract those and we still get the same positioning of 2, -5. So depending on how your vectors are positioned will depend on how you want to operate them. So you can add them and subtract them, you can move them around back and forth, but you just have to keep track or have to make sure that when you're finding your resultant vector, you are going from a beginning point to an ending point. And those beginning and ending points have to follow a path, and that path is kind of the heel to toe is how I like to call it, the heel to toe positioning of your two vectors, or 3 vectors, or 4 vectors. So they just have to follow a path as if you were walking in it, and that's how you can find your resultant vector. I hope that helps.